Hello there. So if you're new to installing alarm systems, one of the first things that you'll need to understand is how the various sensing devices communicate back to the alarm control panel. So we've got a couple of sensing devices here. There's the PIR and there's the door contacts, flush mounting and surface mounting. Very common devices used in, well, all wired security systems really. So we're going to see how they communicate back with the control panel. So there's the control panel with the wiring pulled back, ready to be connected up, and that's what we need to understand, exactly what we're doing when we're connecting these devices back up. Now it might not come as any surprise to you to be told that the way these devices here communicate with the control panel is by using electrical contacts. So that's not rocket science, is it? An electrical contact is basically a switch. But here's the thing, electrical contacts come with two different configurations, normally open and normally closed, and it's important to understand the difference between NO, normally open, and NC, normally closed, and why we use the one that we do use on our alarm systems as we're wiring the devices in. So that's important to know. So look out for that as we go through the video. I'd just like to draw your attention to an online instructional course I've got on Udemy. The link is in the video description below if you'd like to go over there and have a look. It consists of over 5 hours of really good instruction on how to install a hardwired domestic alarm system, and it's using the Texecom Veritas C8 system as the main control panel. So I'll show you everything you need to know about installing alarms in that video if you'd like to have a little look at the preview. But as for now, let's get back to the main point of discussing our normally open and our normally closed contacts. So I hope you enjoy this little video that I've put together for you. Each sensing device in an alarm system communicates with the control panel by means of a switch, which would normally be called a contactor or a set of contacts. Now a switch can be described as being normally open or normally closed, and therefore the circuits that they are associated with would be referred to as normally open or normally closed circuits. So here's a diagram which includes a normally open and a normally closed circuit, and it consists of, first of all, a DC power supply, which is quite probably a battery, the normally open part of the circuit, which simply consists of a switch and a light bulb or lamp, and then the normally closed part of the circuit, which is a little bit more complicated. It consists of a switch still, a normally closed switch this time, a light bulb, but also there's this component here which is a resistor, and this component which is known as a transistor. Now, don't worry if you're not familiar with circuit diagrams or components. The explanation is fairly simple. You just need to remember the principle involved. So let's start first of all then by having a look at our normally open circuit. Now what we have here is we have a light bulb which is supplied via this normally open switch here. So in the position it's in at the moment, obviously it's not going to turn on because the electrical current cannot flow through that switch in order to energize the light bulb. But of course as soon as we close the switch, then the current can flow and the light bulb illuminates. So that is very simple. But let's move on to our normally closed circuit, which is a little bit more complicated. Now, as I said earlier, this device here is known as a transistor, and it's a kind of, you could think of it like an electronic switch. And what it is this part of the switch here is known as the base, and if you pass a current through the base into the switch, it turns it on simply, and this part of the switch becomes like a switch. Once current flows through here, it turns on and the light bulb can come on. So this part of the circuit here is a resistor, and that allows current to flow. So at the moment there is current flowing in this part of the circuit, but because the switch is in the closed position, this point here and this point here are at 0 volts. So the base of the transistor is at 0 volts, and any current is flowing directly back to the 0 volts of the supply. So in this position here, the transistor can't possibly be switched on and the light will remain off. But if we open the switch, what then happens is the voltage at this point here on the base of the transistor rises because it's drawn up towards the positive voltage by this resistor here, and the current that was flowing through this resistor to earth via that switch, because the switch is now opened, it flows into the base of the transistor, turns it on, and the light illuminates. So I'll just show you that again. With the switch in the closed position, no current can flow into the transistor, it's turned off. Open the switch, current flows into the transistor, turns it on, and the light comes on. So there you have a normally open circuit and a normally closed circuit. So we said earlier that each sensing device communicates with the alarm panel with a switch or a contactor, but which of these two options are we going to use? Are we going to use a normally open switch, or are we going to be using a normally closed switch? Well, the answer to that question is we have to use a normally closed switch, and the reason for that is quite simply the normally open switch is too easily defeated. If you think about it, and if somebody came along, if say this was part of our alarm system, this was our sensor, and if somebody came along and cut the wire just there, it wouldn't make any difference, would it? The switch was open before, the lamp couldn't come on before. If somebody comes along and closes the switch, the lamp still won't come on. So nobody would know the difference. The alarm control panel would not sense that there was any change in the state of that switch if this cable had been cut. But on the other hand, if you came along and cut the cable in this position here, immediately what would happen would be it would be the same as opening the switch. So the light would come on, or if it was an alarm control panel, the alarm control panel would be notified, and it would either signal an alarm condition or a fault condition immediately that wire was cut there. So this one is easily defeated, the normally open switch, whereas the normally closed switch is fail safe. So there we have the difference between normally open and normally closed circuits and contacts.